Right, so in the last week we've been looking at how to work out if a molecule is polar or not. What I'm going to show you very quickly is another way physically that we can see. What will happen if something's polar is that it's got a delta negative and a delta positive side to that molecule. If we put it near, for example, a negative charge, then the negative side of that molecule will be repelled by that, so it'll push away. However, if it's non-polar, then those dipoles are only temporary, so they're not there often enough to actually be repelled. So the prediction we're going to make is that a charged rod will have an effect, either an attractive or a repulsive effect on something that is polar. So in this one here on the left, we've got water, and we know that water is a polar molecule. It's been our example the whole time. So what I'm going to do is just charge up this rod. It doesn't matter whether it's been positively or negatively charged. We're going to see if it attracts or if it repels the stream of water, and then explain why. So there's our stream of water without the charge there, and we can see it goes straight down. And then we put our charged rod near it, and it starts to deviate towards the rod. Just get it charged up again before I lose too much. Okay, and we can see that it does actually deviate towards it. So that means that the charged rod, let's say for argument's sake is negatively charged, isn't actually repelling the negative side of it, it's attracting the positive side of the water towards it, so the hydrogen end, as it were. Alright, if this was non-polar, this wouldn't happen. It's only because it has a permanent dipole this can happen. In here I've got cyclohexane, so C6H12, which is a circle, actually hexagon type shape. And because CH bonds are all non-polar, and because there are no lone pairs of electrons to make the charge asymmetrical, we would expect this to be a non-polar solvent. So it should only dissolve other non-polar things like iodine, and it should not be attracted nor repelled by this charged rod. So let's see. There's it running just straight through, and I've put the charged rod near it. Maybe I haven't charged it enough, so let's give it a bit more charge. It's rather hot, so I can be pretty confident that it's pretty well charged, and I'm getting absolutely nothing from it. So that's a physical observation that we can make to just get that idea, is it a polar liquid or is it a non-polar liquid? Or solvent is probably the word I should use. Alright, so that one there you need to be able to justify. This one deviated because having a permanent dipole allows the stream of liquid to be attracted to the charged rod, because the opposite dipole will be attracted to the charge of the rod. This one only has temporary dipoles. They're not there long enough to actually cause the whole stream to be attracted or repelled, or be attracted to the rod. Okay, stop there.